Welcome back. So today we're going to be looking at page 276 in your notebook, and you should have a foldable that looks like this, says Pythagorean Theorem. So a couple things that we're going to do here, I already have them drawn out for you. So you have a triangle that's on your paper. We're labeling the different pieces of a right triangle. So we have a leg and a leg here. Those are the two sides that are adjacent to our right angle. And then we have a hypotenuse. That's across from our right angle. And so since we're talking about Pythagorean theorem, we want to talk about these pieces in relation to the Pythagorean theorem. Our Pythagorean theorem is a squared plus b squared equals c squared. So then we need to know, what is a, b, and c? Well, a and b are the legs. It doesn't make any difference which one you choose for a and which one you choose for b, just as long as the legs are a and b. And then C is your hypotenuse. Okay? So C is the hypotenuse, A and B are either of the legs, whichever one you want to be A and whichever one you want to be B. Okay, so now let's go to the inside of our foldable, and we're going to start looking at some vocabulary. So on this first page that we have, we're going to start out with just what is a right triangle. So a right triangle just means any triangle that has one 90-degree angle. We can't have two 90-degree angles, because if we had two, that would already give us a sum of 180, and we know that every triangle, when we add the three angles, should give us 180. So that's why we say just one. So any triangle, I'm going to use the triangle symbol, with one 90-degree angle. Okay, and then if it's a right triangle, then you can always use the Pythagorean theorem. Okay, we can always use the Pythagorean theorem if it is a right triangle. All right, so our next two boxes down here, for these we're going to have the hypotenuse and the legs. And we kind of already just talked about these. Zoom in just a little bit there for you. So we already talked about these just a little bit on the front side, so we're just actually going to put it in word form instead of the picture descriptions that we did on the front. So the hypotenuse, we said that was across from the right angle. And I'm just going to use my angle symbol there. Other things that we know about the hypotenuse, this is the longest side. Okay, so if we're just looking at three lengths of triangle sides, the hypotenuse is always going to be the longest of the sides. And then we use C in our Pythagorean theorem. So we're going to use C to tell us the hypotenuse. So then for the legs, these are the two shorter sides. Of our right triangle. Okay, and then the other thing that we said about these is that they are adjacent to the right angle. All right, and then we use the letters A and B in our Pythagorean theorem to tell us that they are the legs. Okay. All right, so then one last piece that we want to have here. So a fact We have the two legs can be congruent. If they are congruent, then this would make an isosceles right triangle. However, they don't always have to be congruent. Okay, they can be congruent to each other, but they don't have to be congruent to each other. So it's really important to keep in mind as we're working through some of the practice problems. Just because they look like they're equal doesn't mean that they are, because they don't have to be. Okay. All right, so then from here we're going to go to the inside of our foldable. We're going to start on the left side with our uses for the Pythagorean theorem. We actually have two uses, two times that we're going to be using the Pythagorean theorem. The first use, this is the most common, the one that most people remember, so you can use the theorem to identify missing sides of a right triangle. Okay, so that's like these examples here. Number one, we have a right triangle, and we know one of the sides is 20, one is 25, and the other one is x, so we're not sure what that one is. So we can use the Pythagorean theorem to help us find this missing side. Okay, so for this one, you plug in the information and solve. And your answer, you should be ending with a square root. Okay, so let's take a look at an example here. So example one, our Pythagorean theorem says a squared plus b squared equals c squared. And yes, when you guys are working on your practice problems, I do expect you to be writing down the Pythagorean theorem like this and then plugging things in. Just because the more you write it, the more you will remember it, and then you won't have to have it on a note card because it will be memorized. All right, so then from here, we need to identify our A, B, and C. So I'm going to call this one A, this one B, and then our hypotenuse is always C. So plugging these in, I have 20 squared plus x squared equals 25 squared. So then from here, 20 squared is going to be 400 plus x squared. 25 squared is going to be 625. So then my next step, I want x by itself. I'm going to subtract the 400. So I get x squared equals 225. Still need to get my x by itself, so I need to get rid of this squared. So the opposite of squaring is a square root. So that gives me x equals 15. So then I have my final answer of x equals 15 that I'm going to put there. Okay, we'll do another example of that method. So then down here for number two, this time our hypotenuse is what's missing. So that's our C. So then the legs, again, they can be A and B, whichever one you want to be A and whichever one you want to be B. So we're going to write A squared plus B squared equals C squared. So plugging in the information that we have from our picture, I'm going to say 15 squared plus 36 squared equals x squared. Now I'm going to find my squares. So 15 squared, we said was 225 in the last problem, plus 36 squared is 1,296. And then we still have our x squared. Now we're going to add these two together, and we get 1,521. We still need to find x though, so we're going to do the square root again. So we get x equals 39. X equals 39 there. Okay. All right, so that's our first use for the Pythagorean theorem. Our second use for the Pythagorean theorem is we can prove that a triangle is right. So for number 2, you can prove 3 sides of a triangle make a right triangle. Okay, so we can prove a triangle is a right triangle if we know the 3 sides using our Pythagorean theorem. So again, we're going to plug in the numbers. And the left, I'm just going to call that L, the left side must equal the right side. Okay? All right, so let's take a look at some of those. So if we come over here to the last column, we have some examples here. So looking at this first one, we have a 3, 4, 5. So we said on the front that our hypotenuse is always the longest side, so that's going to be our C. The others can be A or B in whichever order. So I'm going to say A squared plus B squared equals C squared. And I'm going to plug it in. 3 squared plus 4 squared equals 5 squared. 3 squared is 9. 4 squared is 16. 5 squared is 25. So then I'm going to add together my 9 and 16. I get 25 equals 25. Now it said over here, okay, we're going to plug in the numbers, and the left side must equal the right side. So when I look at my example, my left side equals my right side. So up here it says, do the following sides make a right triangle? Since they are equal, I'm going to say yes. And then why or why not? I'm going to put that Pythagorean, and I'm just going to abbreviate. Pythagorean works. Okay. All right, so we're going to try another one down here. Number 6, 7, and 8. So 8 is my biggest number, so that's going to be C. So we've got 6 squared plus 7 squared equals 8 squared. 6 squared, we have 36. 7 squared is 49, and 8 squared is 64. So then adding these two together, we should get 85. And then on the right, we have 64. So since these do not equal each other, then we're going to say no. Pythagorean doesn't work. Okay, so for that one, it did not work. All right, so we're going to actually pause right there because I want you to try to work these two by yourself. So I'm going to pause for just a moment so that you can try to do those independently. And then I'll be right back here in just a few minutes and we'll check your work. All right, so let's see how you did. So on C, we should have had 10 squared plus 24 squared equals 26 squared. So then when we plug those in, 10 squared, we get 100. 24 squared, we end up with 576. and 26 squared should be 676. We add the 2 together on the left. We get 676 equals 676. Okay, so we know that these are equal, so we can say yes, this is a right triangle because Pythagorean works. Okay. So then the second one that you were working on was this 11, 12, and 13. So we should have had an equation of 11 squared plus 12 squared equals 13 squared. So then 11 squared is 121, 12 squared is 144, and then 13 squared is 169. Adding those together, we end up with 265 equals 169. These do not equal each other, so we're going to say no, this is not a right triangle because Pythagorean doesn't work. Okay. So then I have just one last thing that I wanted to do over here. We've got this little starburst going on. So you may have noticed we had 2 that worked over here. Now this first one up here that works, this is a 3, 4, 5, and this is a special type of set of numbers where the Pythagorean theorem works. So we have some numbers will always work. And they are called triples. They are called triples. So an example of a triple is a 3, 4, 5. So anytime you see a combination of 3, 4, 5, that could be a 6, 8, 10, or a 9, 12, 15. So they could be multiples of this series. Those will always work. Another one, our other example that worked, this 10, 24, 26. Well, this is what we call a 5, 12, 13. So I'm going to write that one down as well, a 5, 12, 13, because that's another one of our triples, and that always works. So you'll notice this one, we took the 5 times 2, the 12 times 2, the 13 times 2. That's how we got the 10, 24, 26. Okay, so a 5, 12, 13 is another of our Pythagorean triples that will always work. Okay, all right, we'll talk more about those triples at a later time. That's all that I have for you today. Make sure that you have the entire foldable filled out. So you should have, I'll back up here just a little bit. You should have all of the examples done. You should have all of these bubbles filled in. Vocabulary, you should have all of those bubbles filled in. And then the front of your foldable, you should have your triangle labeled with A, B, and C, as well as leg, leg, and hypotenuse. You should also have your Pythagorean theorem written down with arrows identifying which of the letters are the legs and which is the hypotenuse. Okay, all right, that is again all that I have for you today. Have a great day, and I'll see you in class.